Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good evening. Okay, today we will discuss about our IM4 Lab ECE 655 uh, for the coding about color and voltage. So let's see our coding uh, coding about potentiometer. Okay, let's go. First, I will discuss line by line about our coding. At line 1 until at line 4, it's about a library that we use is import time, import board, import analog IO, and NeoPixel. So the time is used for sleep with it to pause between readings. Board is give names for the microcontroller pins such GP28 and GP14. Analog IO is provide analog in to read analog voltage, which is ADC, and NeoPixel is to control a NeoPixel LED. So the next one is ADC, which is potentiometer setup. So this create an analog in object called port on pin GP28. This is how you read the potentiometer or any analog sensor, which is voltage. And port.value will produce a 16-bit integer between 0 and 65535 representing 0 volt Vref. So the next one is NeoPixel setups. As we can see is num underscore pixel equal to 5, which is there are 5 LEDs, and the pixel pins equal to board GP14, which is the data pin controlling the NeoPixels. Pixels equal to pixels.neopixel is to create the NeoPixel object. The last one is brightness equal to 0.3, which is sets overall brightness to 30% to avoid being too bright or drawing too much current. Next one is at line 14 until the line 32. So low voltage equal to 0.5 and high voltage is equal to 3.0. This defines the working voltage range. Voltage below 0.5 will be treated as 0.5 volt, and above 3.0 is treated as 3.0 volt. This avoid extreme volume or sensor noise. And voltage equal to max min voltage, high voltage, low voltage is claim the voltage into the low voltage, high voltage range. The level equal to voltage minus low voltage divided by high voltage minus low voltage is to normalize the climb voltage to a 0.0 until 1.0 value called level. Such as examples, if voltage equal to 1.05, which is midpoint, then the level is 0.5. So if the level is equal or lower than 0.5, branch first half, which is green to yellow, and ratio level 0.5 maps level from the 0.0 0.5 to 0.0 until 1.0. So R is integer at 255 ratio divide. So the next one is R, which is integer 255 multiply ratio, which is increase rate from 0 until 255 as voltage move from low to mid, and G equal to 255 keeps green fully on. Result starts at green 0 2550 and move to yellow 255 250 at midpoint. Else branch second half, which is yellow to red. So the ratio is level minus 0.5 divided by 0.5. Maps level from 0.5 until 1.0 to 0.0 until 1.0. The R is 255 to keeps red fully on. G integer 255 multiple 1 minus ratio. Faded green from 255 to 0 as voltage goes from mid to high. The result move from yellow 255 2550 to red 25500 at the top. So next one is while This is the main loop. Read, update, print, and wait. So voltage equal to port value multiple 3.3 divided by 65535, as you can see at line 36. So convert this is to convert the 16-bit ADC reading to actual volt, assuming the reference voltage of 3.3 volts. Port dot value is range 0 until 65535, which is multiplying by 3.3 divide 65535 maps it to 0 until 3.3 volts. Next one is display NeoPixel. It's called from the function above to convert that voltage into an RGB color and set the NeoPixels. Prints, which is output voltage to the serial console. So you can see you can see the numeric reading while presenting. And last one is time sleep 0.1. So the while running, it waits 0.5 seconds between updates and keep updates responsive but not overwhelming 10 updates divided by seconds. So I think we should run our coding. So let's see. So as we can see, the voltage is slowly getting up 0.3, 0 to 0.45, and this time is green, and the color is getting ready to be a yellow, uh, and the color is fully yellow at 1.7 volt, which is at the midpoint, and it's getting to be a red now. So it's fully red when the color is turned no when the voltage is turned 3.0. The red color is the absolutely the true red color. So that's all for our discussion for lab M4. Thank you for watching.